So hope
It is
my
visible, sir.
very good. So as per topic for the day, today we are going to discuss about the linked list. Okay. So as till we have a study one data structures array, right? So why we are used array, we know. Okay. uh, purpose of the any data structure may be linked list or array to allow these data structures. You can talk about the array data structures or the linked list. They are offer a capability to storing list of a set of values and offer the way you can read the value, the way you can access the value. So let us, if you want to store only one value, then generally we can use the primitive data type like int, float, double. So all the primitive data types are storing only one value at a time. If you declare integer x, they can store only one value. Integer y, they can store only one value. Similarly, you want to store another variable, you can take z variable. Sometime these are the independent variables make sense because like name, age, salary of an employee that should be independent. But sometime like we want to marks, the student marks can be multiple marks, maybe English subject marks, math subject marks. So in those scenario we cannot declare marks one variable, marks two and marks three. You can going to store set of value in the form of array. Okay, as we store. So for those scenario you can create the array. Okay, so array can store the set of value of similar types. If you declare array of your int, array of int, okay, so this array data structures are store the list of integer value. So what it is the main concern, the main problem with this array data structure was you have to specify the size, how many number of element you are going to store. You should specify the initial size, or you should know the number of element I am going to store: three element, four element, five element. So this is the one concerns about the array data structure. You should know the number of element which you want to go store, or while declaring array, you should know thus you must specify the size of your array, yeah, length of your array. This is the one drawback. And second, that these arrays are stored in memory as a sequential manner. Like this is the 0%, then 1%, 2%, 3%, 5%. And this all memory block should be in the one chunk. You can, okay. Let us, we have a, some situation. Let's we have a available memory that can store one, two, three, four, five values, but we have not enough space to create. We have a memory, limited memory. Okay, we have a memory, limited memory. In this example, we can store element one, element two, element three, element four, element five, element six. Okay, so for array data structure, if you let's keep this memory is alu occupied by let's variable z. Okay, this variable is occupied by, okay. So now if you want to store you want to create the array of five element, this is the this we have enough memory to create the five element, but we cannot create the array of five because if from here you can start, your next position is already filled, you cannot create array. From this position you can start, Yes, you can start, but you have a only available space is equal to 1, 2, 3, 4. But this is already we have a one fifth element, but we cannot create array because array in the memory need contiguous memory location. So this is a one also challenges while working with the array. So first challenge is what array need a fixed size of memory allocation. You must specify the number of element you are going to store. And second, this number of size, let's specify 5. So in memory side, there must be a block for contiguous allocation of 5 element. If you have not enough space, you cannot create array. Okay. So these two problem, one problem about the size, one problem about the contiguous memory location is solved by linked list. Okay. So linked list is also is a data structure which offer you can store the list set of value. Okay. And also offer you can access any value. But legally say you I don't need your initial capacity. When you don't know the number of element you want to going to store, doesn't matter. Linked list no required the initial size. At a runtime, what number of element you want to store, you can store. Similarly, linked list say कि if I don't know the initial size, then I don't know I I do not going to allocate memory continuously. So linked list offer we can whatever you have a memory. I whenever you first time store one element, I can place anywhere in the memory. Okay. Next time you store new node in anywhere, I place where the space available. I just provide the link between those two. Okay. Similarly, next element you want to store anywhere you have a space available. Just link this state to this. Next time you store here the element. No problem. Just link this to the here. So as name suggested, link list. So all the elements are linked to the next element, next element, next element. At this element, how you are going to the link one element to another element. Surely for linking, we need a kind of address. This element must know about this element. What is my next element? In the linked list, in the in the array, this data, whatever the data you store, this don't know about what is the next data. This don't know about the next data. You accessing array from the index position 0, 1, 2, 3, 4, because we know the next element would be the one position, next element would be the two position, next element would be the three position. This is always in the continuous. But here in the case of linked list, your element can store in anywhere the memory space, whatever the we have left. So problem is that here only in the linked list, how we can make a link between the two element. How can we make link between the two objects? So for that, linked list say I whatever the element you are going to store, okay, I contain two things. One, the actual data part, whatever data you want to store, and the second about the link, the next element link, next element references, where the next element. So these things, that store two value in a one block. So at a times whatever you read, maybe your primitive int float double, at a time only one value can store. Or array you can store, they can store multiple value as many you want. But now linked list say I am only need a storage of two values. One is your data part, your element part. Second is the next element, linked element. So how we can define such a element? By default, primitive data type doesn't offer. So as usual, we can use a class. You can define a class that can contain the two fields. One field about the element, your data. Second field about the address, your next element. So in this case, linked list are going to use the concept of class, and in this class you have only defined two fields. One field can contain your element, and next field hold the link of the new data. Okay, this is the link of your address of your next element. So you can now we cannot say this is the element because the element is the only one part, but they kind of hold a two part. So the new terms known as a this is generally we cannot say also class. You can say this is the one class object, this is another class object, but here linked list terminology say we say this is the node. Okay, so now in the linked list, the element, your data, we are not using these terms, we are saying to the node 1. This is the node 1 contain the element part and the address of your next node. Again, this is the next node. So in the linked list, whatever the data you want to store, that data would be in the form of node. Node 1 contain the two part, data part and your address bus. Again, next, again, next. In this way, they have keep the address of this node, this keep the address of this node. They have a own data part, own data part. So till now, any question? What is linked list?
So this complete part is known as node.
This is node only. Node. This is the node.
And what
Node is
node is
node is
like?
simply one class that contain two field. Field one, field two.
Yeah,
Field one
like
for purpose for storing values. Field two purpose for storing the next block address.
okay.
Next block here block you can say node. So each node have a one part for one field for storing your value, and next field to add store the reference of next node. Next node. If this is the your this is the last node in the linked list, then next part would be the null. There is a no null means now there is a no any nodes are associated in this link. So now this is a one linked list then can hold the three value.
So
जो
the first node,
Hmm,
the first node which contains the memory address of
yes.
the next linked item, it contains the address of the data value of the next node or
No,
the
complete node object. This is the object. This is the complete object. In Java, this is the one object. A one object can contain two value, right? So this is the one object. Okay, one object and address of this complete object hold by this node. Similarly, this is the one Java object. Okay, address of this Java object is stored by this place, right? So consider node is a simple Java object. In, but we are studying the linked list data structure. So linked list use this terminology, not using the Java object, because linked list is not defined by only Java. Linked list is the concept that is implemented by the C, C++, Java, Ruby, Scala, Haskell, any other language. So we cannot say this is the class or object, but the general terms linked list say this is the node. One node can hold the value part and the address of your next node. This is the next node. Next node again hold the value part and the address of your next node. This is the next node. And if let's we have only three value we want to store, value 1, value 2, value 3, and now next I don't want, so here they store the value, but what is the next? Next would be the null, means they are not going to pointing any element. So in say this is first node of linked list known as a header. Okay, this is a new terminology known as a header, and a last node of any linked list known as a tail. The two terminology: first node of any linked list known as a header, and last node of any linked list known as a tail. So you should know three terms. Node. Node is a Java object which store two field, one field for value, one field for the address of next node. And second concept is your header. Header is a first node of your linked list. Tail. Tail is the last node of your linked list. So this is the theory part. Still any question, doubt with respect to what is linked list?
No, sir.
No, sir.
So anyone uh, ask about the linked list, you can say something, right? So linked list offer the solve the two problem of array data structure. First about the memory. So while creating a linked list, you do not specify the size. Yeah, number of data you going to store. Linked list say कि I can just create one node at a time and store. Next node, whenever whatever the place I get the memory address, I can store next node and just make a link. Maybe next element can be here. 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 Any place you got the memory space, node is linked. So they are not linked list say if I don't need a contiguous memory allocation. The please be note in the array data structure we must specify the initial size, and also array data structure is internally need a continuous memory allocation. In the linked list, no need a predefined size, no need a specify initial size. Second, also no need a continuous memory allocation. Whatever the place, they can enough available space for one object they can place. So this two demarcation you must aware about the both array is a data structure. Purpose of data structure to offer you store set of values and retrieve set of value. The both things array also doing the same thing, linked list also doing the same thing from the program perspective, from the user perspective. Only implementation is changed. Linked list implemented different way, array implemented different way. But purpose of both data structure, array and linked list is the same, work same. They are just storing the list of value. and offer how you can get those list of values. So all the program, whatever you written using the array data structure, the same program can be implemented using your linked list. Program is the same. There is no any new program come, but the only change the implementation. In array data structure, you are forcing the initial size. You need fixed set of contiguous memory location. But in the linked list, we just avoid. In the linked list, don't need a initial size and even don't need a contiguous memory location. So it's clear between the array data structure and a linked list, right?
Yes, sir.
So let us think. For writing linked list, what is the minimum code you have to need? So first thing, as I explained, you need one class. That class name is a node that can have a two field. One field for your data, one field for your address of your next node. Okay, address of your next node. So first I am going you write one class that store only two field. A class name is a node. Here you can store one data part and one part your nest. Nest then hold the address of another node. So this is the only code required here. Let us look. So you write one class name as a node, and here you can define two field. First field like let's say I want to store integer value, int data, whatever data you want. And second part your nest. Nest node address. A question is that what is the data type of nest? What is the data type of nest? Can you think what is the data type of nest?
Maybe the,
String.
No. In if you
it
if
is in the
you,
hexadecimal, I think so, the memory location.
no. Let us hear. Yesterday you discuss about the employee class and student class. Student one, student one, S1, student S2. Okay. Study you discuss, and here I say I'm say let's here I say class. Okay. Class student study you discuss, and here you can create student S1. Okay, and then here what you can assign, you can assign only, so you know okay, here you can only assign S1 variable. That means you are only can store the value of your another same type object. So here what say S3 hold the address of this object, right? Study we discuss. So similarly here what happened in the case of here your s1 variable, this s1 variable holding the address of your student object, the student object one created and holding the address of your student class. So here this s3 also stored the address of s1. So here what kind of data types here, what the value you are assigning here. Here in our case this is the node and this is also node. if you want to store the reference of here, so what is the data type? Should be node, because we are storing the address and references of another node. Is it clear? Whenever you say here any variable, you specify the data type. That means you only those types of value you can assign. Yesterday here you assign any employee variable, you cannot assign, right? Or any float value, not. Because you say ki this S1 variable are only store the student references. So in our scenario, we need a want to store the reference of your next object. But what is the next object? Next object also be the node. So this is the first node, and next element also node. So here we are going to write the node data types. Is it clear?
Yes, sir.
So this is the minimum things you need. The question is that how I going to use
But
this? Yes.
yes, like here we are using node in node class. Like the other times we are using like point in a circle class, so it look like it has a relationship. So
Yes,
it
right. Right,
look like
correct.
node as a node.
Correct. Similarly, like here, you say one node can hold the address of another node, right? So holding means this class node has a relationship with another node, right? So let's think how we can use it. Generally, for using, we need a constructor. You define your constructor. We have a constructor. Okay. Uh, so let us say constructor private, so that key no one create any node using the blank value, right? Always node need some data, right? So this mark you as a private. So as of now, just leave it. Minimum changes. So later we can use. So now it's clear. Now you have a node. You can create the node object, right? So here you can say node object. Okay. Let's node one equal to new node. Okay. But question is, wh- what is the data and what here data? Data we can pass any integer number. Let's 34. And what is the next value I pass? What next value you can pass? So here if so here you can declare any node and two, then you can simply declare null. So null is the one reference that can assign in any object. That means here what do you mean by that? This n2 variable is not going to point to any Java object. Okay. So here next node what would be I don't know. So for purpose I write here only null. In this way you can create their node object. So currently you are going to
So it
create
means
one node, and that is the value is the 34. Value is the 34. What is the next node? Currently I don't know what would be the next. So just specify null. Null indicate currently this next variable does not to point any object. Okay. Whenever next node create in future, so I know, give me the address of this, I store here. So for whenever you are creating a first node always start with the any node first time creating, you know the data part, but you don't know the what is the next. Okay. So next initially allow null. Null refers that this is the next variable does not holding any further object. Null means they are not referring any object. Yes, Balwant.
Yeah, I understood. Like here it means just we are creating one node.
Right.
So like it have no next reference. And if we create node n2 and give it
Let
data
me create
something,
node 2.
yes.
Node 2.
Here we can write null and here we will write n2. In line 6
Yes.
we will write n2
So
if we
here
want to link those.
you write like in this way. Here you can write up now I can write n2.
Okay. So it means we have two nodes and n1 will be
So
header.
here your first you created n2. Okay. This is n2. N2 is your data part 34 and next part is your null. Okay. Next you create another node n1, n1, n1. N1 is the okay same by default 34 data. And what is the next? Next would be this. Right? You are assigning the n2. In this way, two nodes are linked. So first time, whenever you're creating any node, at that time you hold the value, but next would be null initially. So is it right? And generally one minimum thing, if you just let's you s out print here. If you print it, it will print like a data and some value. Okay. So one more thing you have to do here, you have to override the twisting method, right? So that you can print the actual uh, data, right? Now if you run it, so whenever you are printing any Java object, by default twisting method invoke, twisting here twisting print your node null, and you notice next node contain the next node itself, right? So now this node 1 linked to this node, right? Are
Yes, sir.
correct. So this instead of right. So this is the minimum thing. But now here we have simply not created any linked list. Here you just created one class. One class have a constructor. One class have a method. Right. So for creating a linked list, we need to write some program where I want to add some value. I want to get some value. So let us write those. So so let us create a class my linked list. Okay, linked list. Now this is your linked list class. Okay. Now linked list, I explain linked list have a three terminology you know. One is your node. Okay. Any number of node you can create. Okay. Any number of node you can create. And first node as a header, last node as a tail. The- So whenever you're going to create your linked list, you are going to use the header part and your tail part and node part. So in the linked list class, you have to one your node is a header, you can say head, right? And next element you have a tail. And Next question, whenever you're going to create linked list, okay, so you want to add node 1, add node 2, add node 3, add node 4. So you have to offer one add method. Like in this class, you need some add method. So which they can add this node, right? So here you write one method like add node, add node. They receive a node input. What the node you want to store, and just let us assume you return a bit. So let us someone create the your linked list object. Now create the someone your linked list object, and here uh, now they can do add node. Okay, add node or simply say add. Okay, that means you pass the node simply. Okay? And they here you have a node like n1, n2, n3. You can any pass. Or simplest way you can say just add function are expecting you give me the only one integer data type which you want to store data. Okay, so here say just give me the data I want to store. I want to store 35. Okay, so this class is a responsibility going to store this 35 value in the node. So uh, how to do? How we are going to store? If you written add method, but add method is do nothing. So what I can do? You know, any things you want to store in the linked list, you have to create one node, right? One node, and make a linkage, right? So what here you can do? How to make a this? This is the now our developer responsibility. You can create whatever the we are receiving one data. You can create one node and store whatever the user want to value in the data part. Okay. Next time, if again invoke the add method, you create this data and make a link. Next time again someone invoke add method, again you can create this node and put data, whatever the data they want, put data and make a linkage. So this is the code we have to write. Key number of times this method invoke, you can just go add this value in the linked list. So here what you can think. So surely you need to create a node object. Node, let's temp object and equal to new. So here say node whatever we have a data, this is the data part. Okay, and so let us so simple, even you don't need a constructor, always not. Okay, simply node contain only two things. Okay, here say just allow me, I can create a blank data. Okay, initially let's assume we are allowing to create blank node. Now in this node I can say set the add data, what data user pass, right? And this is the thing. But question is that you can create this object. How make a link? First time, okay. Yes, I just now remove it. So let someone invoke again 55. Someone invoke let's 22. Someone invoke let's add 40, 27. So how you our expectation is that from this program our expectation is that 35 should be added here, then 55 should be added here. Next 22 should be added here. Next 27 should be added here. Like, so this expectation we want from this method, right? Is it correct? What is the requirement? User just create the linked list object and add value, add value, add value, add value. Now our this add method is responsible to create this linked list. Requirement clear? Question?
Yes, sir.
Yeah. So let's think how we'll write the code here. Whenever you receive the data, input data, you create the one node because linked list contain node and store the data part. But question is that next time whenever you invoke someone, then what will do? Let's again explain. Yes. First time invoke the add method. You in add method invoke, you create one node. Okay. Let's you create one node, and in node whatever the data user data pass 35, you store the 35. Okay. 35, and then do nothing. Next time again control goes from here to here. Next time invoke for 55. Again you create the new 55, putting the data, putting the data 55, 55. I again return. But you are not making any relationship, right? So you have to write some code here. And similarly, this is the 22. Next time you again create, you can create new node object. Okay. You can put value 22, 22 here, but you not any relationship. So the here we can use the concept of your head
Tail.
and head and tail. This linked list object have this variable head and tail. So whenever you
Tail.
first time create, you can have a two variable head and tail. So you can just point this is the head and this is the tail. Whenever next time you create this node, new node, just change head should be always the first, and now tail should be this. Okay, and you make a relationship head with the next. Similarly, next time, now this is a tail. This is a tail. A new node created, new node link with this tail, and change. This is the my tail. So this is your head. Head always point to the first element. Tail always point to the last element. In this way, in the whatever the tail, next time you create the 27, you can create 27 node, and this is the node. You put the 27 data. Where you want to link this to the tail. You have a tail the last element and link here, and next change. This is the tail is the this tail. So here only not creating object, but you want to store this. Let's check if this is the first element, then head should be blank null. If null, then this is that means ki this is the first times someone going to add the. So you can say head equal to your temp node and tail also the same. Whenever you first time you create the value, at that time head should be null. At that time you can assign. Okay, this is the tail. Okay, so head and tail both are the pointing to the same. Clear? Whenever in our node first node created, then first time this will be null, this should be null. So you say ki this is the null, then what happened, you both variable head and tail are pointing to the same because we have only one element. Whenever next time invoke the, you can create new node and just link to the tail, whatever tail have, link to the relationship and change. Now this is not a tail, this is the tail. Again next time new node created, new node linked to the tail. This is the tail. You create the link and move to the your tail. Now this is the tail. Now this is the tail. So this logic you have to build here. If you are the first node, then the both head and tail are the same node. And after that, always and the end of tail you assign the new. So here, if not a head, then that means a tail part. So here what you say, whatever the tail you have, just assign the new node. Tail means here you are making a relationship. If not first, then tail assign the new whatever the value you created. Are you getting? What next part?
Yes,
What we
sir.
are doing? First time you create your first node. First time head and tail both pointing to the same. There is no problem. Whenever next time invoke this method someone. Now head is not null. So you go to the else part. First time you this create one node. Okay, I create one node and here's a key tail dot nest. Tail, this is the tail dot nest part. Nest part is store the address of this new created here created new of node address of this here. And now you have to change this tail to now this is a tail. So you have to write code ki this is the tail is the new one. Again next time new node create, then again this is the tail dot next you link this and change. Now this is not a tail, this is the tail. Is it clear? So here you have to make a link and also say ki what is the next tail. Next tail is equal to temp. Are you getting here what I'm written here? This is the initial value and this is for all next to next to next to next.
Sir, what is the difference in line 27 and 28?
Again next let us explain. Here say first time you create this node, whenever this method invoke you can create this one node hold the data part only. Here you set data. First time you check head is null, then just point head variable and tail variable both here. Head and tail. Is it okay? If next time someone invoke the same method, you again create a new node, you create the new node. You create the new node and put the data, whatever the data you put here data, and check head is null. No, head is not null. Head pointing to the first this one, right? So go to the else part. Okay, else part. Else part say tail dot next. Whatever the tail currently this object. Okay. What is the next? This. Next assigned to the this temp. Just make a this link. And after that, what you do? Ki now our tail, we have to not this is the tail. Now this is the tail. This is the tail, right? So here I am saying ki the now new tail is the your temp. This is the tail. Are you getting what the meaning?
So, sir, tail dot next it tells us that the
Yes.
next tail
Yes.
will be of temp next
Yes.
node object.
Right. This is the temp currently referring the temp here. Next time, let's again someone invoke this method. Then again you create the new node here. New node you created. New node created. Put the data. Put the data. Put the data. And head is not null. Yes, head is not null. Then go to the else part. What is the tail? Tail is the currently this, right? Tail is the this. So in tail dot nest, whatever tail dot nest, you can say assign this value. This is the temp which created. And next time say ki now next tail is this is the next tail. This is the tail. Now this is not a tail. So it's clear.
Line 27 means, sir, which is the tail of our temporary node. This goes to the next node.
Yes, always this is the first header, and I'm tail is the always last. You can say first or last. You can say a header tail. Last element is the tail, right? So tail always move. Tail always move whenever new element come in the system. New come again. Now become this is your tail. The tail always move the next. The tail always move the next. Okay. So look like these two line of code same. So instead of you can just cut out from here, cut out from here, you can just write out maybe. Tail always referring to the temp node, right? Tail equal to temp, right? So let us again run it. Okay. So let us now question is that here we written, but how there this class some offer method to print all this. What I'm printing here, if I'm going to print here, there is no any method to print all this element. So how to print? So this linked list method also offers some method like void print node. Okay, yeah, display date display. So okay. So function, you know, we have already created linked list. Your header part nest 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 till tail. Okay, so you have to start printing data from the head and go to the nest, go to the nest, go to the nest, go to the nest, and print all the value till until your tail is not null. Okay, so here you can say write one function that just printing s out printing until while let's say your. So like again explain what the logic here you have to write. Let you have this is the your nest node, nest node, nest node, nest node. So here should be your head, here should be your tail, right? Now I want to print all the data. So what we can do? I have to print first this value, okay? Then next value, then next value, then next value. So how to move next? You know, each have a next method. So we are going to one take variable t first pointing to the head, okay, and print the data part. Then again t pointing to the this data, then print the data of this. Then again t point to the this data again, and then t point to the this and data again. So in this way, because there is no any 0 position, 1 position, 2 position, they have a link. So yeah, we are going to create one temporary variable just initializing with the head. Head is always the first element. Get the first element and put the data. Then next element dot next you are getting the next value. Next data dot next again getting a next data, and you are finally printing all the value. So here what you have to write? You say let's node your temp variable just initialize with a header, okay, and check while temp not equal to null. Okay, if it's not null, then just print s out uh, whatever the your uh, temp have a data part print, and just plus and just comma space something. And whenever you print first value, first value, then you have to print next one. So this is the part dot next. So you say कि now our temp become a temp dot next. Okay, now go to the next and next element again print. Go to the next element again print until next become not null. So now this show function you can print here. A my linked list dot show. So let us just instead of comma just link list, right, and run this code. So instead of print line, just make like this. So look like output, look like a linked list. So here the same order we print add data 35, 55, 22, 27. So let us again understand the add method. Okay. So what to do? Whenever you pass 35, you go this add method and again create one node. Okay, one node. So you can create one node. Okay. In the data part, what you pass 35, just store a 35. Okay, and check head is null. Yes, initially head should be null. So just assign head equal to this new node which you created, right? This is a temp created, assign the temp. And after this condition, you say it tail also the same. Tail also is the same. Tail also temp. Next time you invoke 55. So next time method invoke come, you can again create new object. You can create new object. Assign the value, whatever data 55, you assign the value 55, 55, and head not null. Head is the pointing to this, not null. Then go to the else part. Else part say ki whatever the tail is pointing to the this. Okay. Dot next, dot next, dot next. Just store this temp. Just store this temp. Now here you are making a link relationship. And after this condition come again say ki now this is not a tail. Now this is a tail. New whatever the new temporary, this is the tail. So this is the not a tail. Now this is the tail become. Next time you invoke for the 22. Method come. Again invoke new node. Create a new node. Create new node. Again head not null. Then go to else. What is the tail? Tail, this is the tail. This is the tail. Go to the next part. Dot next. Dot next. Link to this temp. Link to this temp. Okay. Your 22. And after that, this become a tail. Now this is become a tail. Next time, again invoke the 27. Next time method invoke, again create new object, or new object created, new node, and store 27, store 27, and say head is not null, not null. Go to the tail, yes, this is the tail. Go to the next part, make assign to the this temp variable. This is the temporary assign. Okay, and after that you say, oh, this is the tail, this is the tail. Now this is not tail, this is not tail. So in this way, you can create the linked list. Whenever I am going to printing this, so and again while in this show method, whatever written here. So we have already created node. Here our head, right? Here our tail, all are the linked. Okay. This are initially or this is the value 35. This is the 55. This is the 22, and this is the 27. So how we are going to print? In so method, you say one temp variable, one temp variable, point to head, point to head. If check this is not equal to null, yes, this is not null, yes, this is not null, then print the data part. Okay, what is the data? 35. Just 35 print. After that, say it temp become temp equal to temp dot nest. What is this nest? Nest just assigned to the temp. Means now temp pointing to this nest node. Here temp pointing to the temp dot nest. What is the nest? This address. That means this node. So again, while you come here, okay, say give me the data. What this T point this to? Give me data. What is the data? 55. Then you can print 55. Again change temp to rest. Now again change temp to temp dot next this. Again print what is the value? 22. Again change temp to temp dot next. Again this temp change to this temp. Again temp dot data 27. 27. Now again assign temp to next. So what is the next? Next is the null. Again you can say this is not null. No, this is the null. So just out the loop and your program is done. So in this way, you are printing data from linked list. Yeah, getting data from linked list. Yes. Any doubt with this question? How we can create linked list? Now we can create linked list. Offer one add method. They can add any number of element in this linked list. There is no any size. Okay, one element, two element. You can add any element. Okay, you can add element, any element you can add. Okay, you can add any element here. Your show function will return the all the element whatever you want, right? So this is the way you write linked list program. Any doubt, any question?
No, sir.
It will take do some practice, then you will feel comfortable.
Yes, sir.
Okay, this is very important topic for the data structure, you can say. This is the core of your data structure is the linked list, because they are offering, doing, storing list of set of value in the different memory location. This is the memory optimized data structure, right? And there are lots of question maybe in the side interview or outside interview must ask about the linked list. You need a lot of practice on the linked list. You create by in yourself and play. In this linked list, at least multiple classes need to cover. Okay, this is the very basic operations we do. What we do, we are just creating the linked list, creating a linked list just till now. Okay, making a link and just try to read this value. The two operations you done, add value and get value from linked list. Lots of other operations also need in this linked list. First, let's practice of this basic. At least you should know now how what is node, what is header, what is tail, how can make a link, and how can retrieve value one by one. So if you notice, here have a two problem. Here is the one benefit, you don't specify any initial value, right? Whatever number of element you want to add. But in the case of array, you must specify the initial size, right? So that is avoided. And second thing, uh, always we are reading data in array in the form of 0 position, 1 position, 2 position, 3 position, 4 position, 5 position. because they are stored in the contiguous memory location. But here we are not getting data on the position basis. Okay, here we are getting data on the address basis. What is the next address? What is the next address? What is the next address? And this is the one uh, feature of linked list. Linked list are maintain the insertion order. In which order you insert value, the same order you get the value. For let's say you want to get the last value in this array, you can simply say array of your last element index. You can get the value. But in the case of linked list, you want to get the last value, or you want to the middle value. So from header, you can go jump, 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 and then find the this is the middle element. But in the case of array, you can position based, just jump to the position and get the value. So array data structure is very fast in case of getting any element. But in the case of linked list, it's very hard. Always start from head and go next, 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 and then find out the element which you want. So each have some pros and cons. But you notice in the array there is a very problem if you want to insert new value inside the here. All the other value must be shift, right? Left shift. So lots
Yes,
of
sir.
pros and cons because array is a contiguous memory location. Let's see, this is the millions of your size, okay? Yeah, 10,000 million of size. You want to store the value at the first position. The first 999 value you have to first make a one shift, okay? Make one shift, make a room here, right? But in the case of a linked list, all are the node, all are the node. They have just you create one node and change header, header pointed to here, change header, header here. Now you make a link here. So here linked list insertion, putting data in a linked list is very fast. But getting this element is a very slow. From header to jump next, then next, then next, then you find this element. But in the case of array, quickly you can get any position data. You know the position. So some kind of plus and minus for both, but you should know both.
Yes, sir.
So now you need practice. Let us do practice. Still you have any doubt, we'll discuss. Okay?
Okay, sir.
So till now today for any question with respect to
Um,
the node, linked list, header, tail,
No, sir.
no, sir.
good part. So let's close the call. Thank you.
Thank you, sir.
Thank you, sir.